phosphate and bacteria in the reservoir, and it's also used as a pH conditioner. It keeps the pH to be neutral. Okay? It acts as a coagulant by reacting with hydroxide to form aluminum hydroxide, which precipitates from the solution and drags impurities down when it settles. Okay, so it reacts with hydroxides, and aluminum hydroxide is a precipitation. So when it settles down, when it forms precipitation, it removes the impurities. Okay, some of the phosphates, some of the bacteria will be dragged along with the with aluminum hydroxide. So here is what was the information given. Write a complete balanced chemical equation for the reaction of aluminum sulfate and sodium hydroxide. And one information also provided to us was that aluminum hydroxide is formed. Aluminum hydroxide is formed, and it's also given as aluminum hydroxide is insoluble. It's a precipitation. It's solid, right? Okay. And then what is the other product besides aluminum hydroxide? It's going to be sodium sulfate. Sodium sulfate. Okay. Now, when we set the problem like this, the very first thing that we need to do is we have to balance the equation. We have to balance the equation. That's the first step. Okay. So I might tell you one secret about balancing the equation. Maybe the easiest way. If you have a polyatomic ion, okay? If polyatomic ions are involved, I would start with the polyatomic ions first. I mean, it's not a rule. It's not like you have to do this, but it's like an option, right? Start with the polyatomic ion first. Make it easier, okay? That means, for example, here, how many sulfate you have?
3.
You have 3. How many sulfate you have?
1.
1. So to balance the sulfate ion, what do? You put 3 here. Okay? Now, and for example here, you have 2 aluminum, okay? You can put 2 here. Okay? And how many hydroxide we have? See, we're not going to count OH. How many hydroxide we have?
6.
We have?
6.
We have 6 OH. Okay? Are we clear on that? We have 6 OH. So what do I do here?
6.
I'm going to put 6 here. I'm going to put 6 here.
So why is it again?
36.
No, I'm talking about the OH over here.
The OH? Because the OH is like, it was 3 here, right?
Mm-hmm.
It was 3 here.
Oh, because it's here in the front?
Yes, but if I put 2 here, it's going to be
6.
6.
Oh, okay.
It's going to be 6 OH here. So that's why I put 6 here. Okay? This is how the equation looks like. Now, now the question is, if you have 0.655 grams, let's say 0.655 grams of aluminum sulfate was given to you, okay? And this is given to purify the water, and how much precipitation we get. In other words, how much aluminum hydroxide we get. What is the amount of aluminum hydroxide we get from this quantity, from this value. Okay? So in order to solve a problem like this nature, what is that we need to do? That is, the purpose of balancing equation is actually to compare the quantity of aluminum sulfate with the quantity of aluminum hydroxide. Okay? That means 1 mole of aluminum sulfate, what is the ratio? 1 mole of aluminum sulfate is 2 moles of aluminum hydroxide. That's the ratio, 1 to 2, right? But you know, the relationship is not in moles, the relationship is in mass. It's like mass to mass. So we convert this mole ratio to mass ratio. So aluminum sulfate, how many grams? What is 1 mole of aluminum sulfate equals to?
1 gram.
In terms of gram.
Which kind of mole on that?
Yes.
Then what am I supposed to say?
1 mole of aluminum sulfate equals to how many grams?
342.1.
342. Even?
No, 0.162.
Okay, you know what? I'll go with 342. Okay, 342 grams per mole. How did we come up with this? Finding the atomic weight of aluminum, which is 2 times 23, the atomic weight of sulfur, the atomic weight of oxygen, and multiply that by their subscripts, by their respective subscripts, like 2 times 20, 23 or 24. Aluminum has what?
27.
27, okay, 2 times 27. That's the weight of aluminum. And 3 times 32, 32 or 31, sulfur?
32.
32. And then oxygen is 16, so 6 times 16. Okay? You add them up together, and it came up with 342. Okay? How about the weight of aluminum hydroxide? 27 plus 3 times 16 plus 3 times 1, right? 27 plus 48 plus 7, right? It is going to be what? Anybody can give me the answer? Yes. If you add 27 and 48 in 3, what do you get? 78. 78. 78 grams per mole, right? Now, remember we have how many moles of aluminum hydroxide? We have 2 moles of aluminum hydroxide. So, according to this equation, the chemical equation we have here, we can say that 342 grams of aluminum sulfate provides how many grams of aluminum hydroxide?
78 times 2.
78 times 2. 78 times 2, which is 156. 156 grams of aluminum hydroxide. This information actually comes from the equation, from the balancing equation. Okay? If that is so, if that is the case, then let's say what was given to you, if you have been given 0.655 grams of aluminum sulfate, how many grams of precipitation will be eliminated from the water after you add the reagent aluminum sulfate? What is the amount? So we can make a comparison like this. Every 342 grams provides me 156. If I have 0.655 grams, it's X.
You want the answer?
Yeah.
I got 0.195 grams.
0.195
195 grams
grams of what?
aluminum hydroxide.
Aluminum hydroxide. Okay, let's see.
I got 0.298
0.298 grams of what?
grams of aluminum.
Aluminum hydroxide. Okay, very good. Okay, we have 2 answers here. Anybody has a different answer?
Can I see that?
Yes.
0.299. 0.299.
0.299. Well, this is pretty much closer with the second one. Okay? It's pretty much closer to the second one. So X will be the way how we solve the problem is we use a criss-cross method, right? X equals to what? You multiply 0.655 by 156. I'm sorry? Then divided by 342. Okay? So you get 0.298, okay? Or 0.299, something like that, grams of aluminum hydroxide. That's how we solve the problem, you see? So the idea is how we set up the equation. Okay, how we set up the equation, how we change the chemistry problem into a mathematical problem. That is the key part here in stereochemistry. Okay, so the very first step, we balance the chemical equation and we compare reactants to products And then once we compare reactants to product by using their molar mass, their respective molar mass, then we're going to look the given value, what was given here, and see how much product we get from the given value, how much product we get. Okay, from the equation, we have this. We have 342 grams of aluminum sulfate provides 156 grams of aluminum hydroxide. That is from this equation. If that is the case, then we move into here, which is given value. Then we say, if we have 0.655 grams of aluminum sulfate, then how many grams of aluminum hydroxide can be generated or can be produced? So we use crisscross and we can get the answer. Okay? So actually, we're not that much interested with sodium sulfate because sodium sulfate is dissolved in water. But aluminum hydroxide is not dissolved in water. So it is a concern of the environment because it forms precipitation. So how much precipitation we get, how much sediment we get is really a critical question here. So we wanted to know whether we add this aluminum sulfate and to what quantity, to what extent we have to add in order to get the threshold or the maximum amount of aluminum hydroxide. This is something that very practical that we can able to tell or
You have to
identify.
explain that because I did it exactly how you did it and I got a different answer.
Okay, what was your answer again? 0.15,
Well, I got
right?
it, and then I got a different answer when I just did it again, so I don't know. Somebody explain it to me.
Okay. Okay, let's go back here. This is the equation. Up to this point is clear, right?
I got all that. I'm talking about the math.
The mass part. Okay, the mass part, we multiply to get x, right? We multiply 0.655 by 156. If you multiply 0.655 by 156, what do you get? The numerator part. Williams.
Hold on.
For comparison, some of you can calculate
I
that.
got
and then we can
102.18.
102.18.
102.18.
Okay. That is for if you multiply.
Plus 161.
0.655.
0.655 times 156.
Good. And divide this by 342.
And you got that 0.29.
Did you get that? First, you multiply 0.655 by 156. You're supposed to get 102.18. Once you got that, you have to divide this by 342.
Because in the book, it says you have to, in between, you have to put that 1 mole equals to 2 moles of the other substance. And I did that, so that would be 156 times 2 times.
Yeah, that's what I did. Okay. You see here, 1 mole of aluminum sulfate equals means stoichiometrically equals to what? 2 moles of aluminum hydroxide, which is this. This is 1 mole related with 2 moles. Right? Now, since we are dealing with mass to mass,
That's what happened. You multiplied it before. I'm saying I did it. I got the grams of 1 mole of aluminum hydroxide, and then I put it in there.
but we have to multiply by 2.
Right.
Yeah, we have to multiply by 2. Because 1 mole of aluminum sulfate is 342 grams. 342 grams equivalent to 156 grams of aluminum hydroxide. Where does that 156 comes from? Because it was 78 if it was 1 mole, but you multiply it by 2.
I think you did balance the equation.
Yes,
I
yes.
think you did balance the
Did you balance the equation?
Yeah.
Okay.
I did that. I did that. That's not. It's the math. It's the math afterwards.
Okay. So is that clear now? Can we move to the next one?
Keep going.
Okay. So this is the one that you did, right? Oh, yes. Okay. Okay. Limiting reactant, very good. Okay, it's it. Yes, okay. This is the next topic that I want you to discuss with you. I asked you also the analogy, right? Have we discussed about the analogy? About the bread and the cheese stuff? We did that, right? I want you to apply that idea, okay? I believe it was 10 slices of bread and 7 slices of cheese. 10 slices of bread and 7 slices of cheese. And we want to make a sandwich. To make one sandwich, it needs 2 slices of bread and 1 slice of cheese. If I have 10 slices of bread and 7 slices of cheese, how many sandwiches I made? 5. Now, what is the reason behind this? Why should I make 5 only?
You only got 10 slices of bread.
Because we have only 10 slices of bread, right? Which one runs first? The bread. The bread runs out first. We run out with the bread first, right? So left over, there are 2 cheese left over. Think about that. 2 cheese left over. The bread runs out first. This happens in chemistry. This very example happens in chemistry. In chemistry, you have 2 reactants, right? Always your expectation is the 2 reactants are combined together, you get the maximum amount of product. That's your goal, right? Reactants combine to get a product. Any chemist, efficient chemist, wants us to get 100% product. Nature would not allow that. You don't get 100% product. One of the reactants, unfortunately, will be consumed faster than the other. Just like slice of bread is run out first. Okay? Maybe the condition of molecules might not be perfect. Maybe the reaction needs a catalyst and you don't get a right catalyst. Maybe you didn't give adequate temperature for that reaction. The temperature or the pressure condition might not be proper in order for you to get the 100% product. So sometimes there's a situation that one of the reactant consumed faster than the other and you don't get your 100% product. It's not perfect, right? So that's what that is the idea actually. We're going to apply the same idea, we're going to apply here in cheese and slice of cheese and slice of bread. Okay? So limiting reactant means it is the reactant that runs out first in a chemical reaction. The reactant that runs out first in the chemical reaction. And limiting reactants also limits the amount of products that can form. So how much product it can form is limited by the limiting reactant. Okay? Just like the sandwich was limited by bread. Right? Just like the sandwich was limited by bread. Okay? Because maybe you may have 10 or 20 slices of cheese, but that doesn't answer the problem. That doesn't solve the problem. Because bread is going to limit. So the only sandwich you can make is 5. So here also, the limiting reactant, we should know which one is the limiting reactant and the excess reactant. Okay? So the limiting reactant is always depend how much product is forming. Okay? Example, we have here, we add an excess of water to the reaction that forms phosphoric acid, form water and P4O10, which is P4O10, is tetraphosphorus dioxide, right? Now, if we may have excess amount of water, water is not an issue, okay? We get water, maybe we get plenty of water, but we don't have that much P4O10, right? So how much phosphoric acid, depending when you do the reaction, depending on the quantity of P4O10. So what is P4O10? It is a limiting reactant. It's a limiting reactant. What is H2O? It is excess reactant. So you have limiting reactant, you have excess reactant. So limiting reactant is the one that determine the amount of product, the one that runs out first. Yes?
How can you tell between a P4O10, between the 6H2O? How
Yes.
can you tell which one is like?
Yes, yes. That requires calculation. That requires a
You
calculation.
can
Okay.
just tell by just looking.
No. How can we have? No, there's no way that you can tell. Okay, but at least you can guess. You can guess. I mean, if you ask me right now, I don't have the quantity, but I would say I don't think water will be that much expensive versus with P4 or 10. Okay.
And we have like, we add excess, it says that we add excess water, so that it's excess.
It was written here. Yes. Yes, that was written here.
That's
Yeah.
why.
Yeah, that is written here. But at least sometimes we have to use our chemistry intuition also. Okay. Well, in this case, yeah, we had an excess of water, which is given here. Yeah. Okay. Let's see this example here. Electronic grade silicon is used in electronics industry. Is made from the reaction of silicia. Silicia is SiO2. With carbon at 2000 degrees centigrade. Okay? If 1000 moles of carbon are heated with 550 moles of silicia, what is the maximum number of moles of silicon can be formed? Okay. Now, here is the thing. Silicon is made from this compound, silicia, SiO2, and then it is extracted by using carbon. And they use the temperature at the range of 2000 degrees centigrade. And then they purify silicon, okay? And then they get carbon monoxide, okay? Now, the question is, you have been given 1000 moles of carbon, 1000 moles of carbon is given. You have been given 550 moles of silicia, which is this compound here, right? Based on this information, the question is, what is the maximum number of moles of silicon that can be formed? How much silicon that we get? Okay, how much silicon can we get? So we have to make a chemical reaction. We need to see from the equation that how much silicon I get from silicon dioxide, from silicia, how much silicon I get from 2 moles of carbon. Okay? The key part again is what? The key part is balancing the equation. Okay? This number, the mole ratio, tells me something. It tells me something, right? It tells me that 1 mole of silicon dioxide, every 1 mole of silicon dioxide provides me 1 mole of silicon. The ratio is 1 to 1. Every 1 mole of silicia provides me 1 mole of silicon. Okay. If I have 1000 moles of, no wait a minute. If I have 500 moles of silicia, 500 moles of silicia, how many silicon I get?
500.
500.
550.
550 to 1,000.
If I have 550 moles of silicia,
It's going to be 550.
it's going to be 550.
Oh.
The ratio is 1 to 1.
1.
Are we okay with this?
Yeah.
The ratio is 1 to 1. Right? Look, 1 to 1, right? So if I have 10 silicia, I will get 10 silicon, right? If I have 550 moles of silicia, how many moles of silicon I get? 550. Does that make sense? Right? Okay. Let's bring the issue here between carbon and silicon. Let's say the amount of carbon that was given to me was 1000. 1000 moles of carbon.
It would be 500.
How many silicon I get?
500.
How many silicon I get?
500.
How many silicon I get?
500.
500. How many of you say that's 500? Yes, 500. Now how many of you say no? Different numbers, doesn't matter. Okay, the ratio, look, 2 moles of carbon provides you what? 1 mole of silicon, right? The ratio is always half. Okay, if you have 20 moles of carbon, how many silicon you get? 10. If you have 100 moles of carbon, you get half of that. Yeah, half of 1,000 is 500. Yes, half of 1,000 is 500. Right? Okay. We got the answer. That's fine. But that's not here what it says. The reactant that forms the least product will run out first. Again, go back with the slice of bread and cheese case. That analogy. The reactant that forms the least product will run out first and limit the amount of product that can form. One of the reactants that gives you the least product means that that reactant runs out first. It's consumed first. And it also says that that is going to limit the amount of product that can form. So what is our maximum amount of product that's formed? 550 or 500?
550.
Okay.
500. Because
550?
500. Because
500.
I was going to present it.
Okay. How many of you say 550?
Are you asking for the maximum amount of the form of the limiting reactant?
Yes.
I'll say 500 because.
to get the limiting reactant, what is the purpose of knowing the limiting reactant?
So we can use the quantity to make the like the best like.
Yes. To know which one is the limiting reactant, it helps you to know what is the maximum product that's formed. Okay. Here Manuel says, for example, 500. Okay. Some of you say the maximum amount of product is 550. Right? Which one is the answer?
500.
Okay, how many say 550 is the answer? 500.
So when you use the like the whole. I'll say.
Okay. Okay, look here. Well, the answer is 550. Okay, the answer is 550. But how do we come up with this? We can calculate the amount of silicon that's formed here from 1,000 moles of carbon. From 1,000 moles of carbon, because always it is half, it is 500 moles of silicon, right? The amount of silicon that's formed from 550 moles of silicon is 550. You have two answers, of course. You have two answers. But the maximum amount you can see here, the carbon will be used after 500 moles of silicon have been formed. Therefore, carbon is what? The limiting reactant. Right? Carbon is the limiting reactant. How do I know carbon is the limiting reactant? It gives me what? The least product. It gives me the least product.
Because like I started with 2 as 550, and then if you multiply 2, it's going to be 110, and then it's 6,000. So you ran out of the carbon. That's why it's not really there.
Yeah. You can say that one. So the one that gives you the least amount is always the limiting reactant.
Oh, okay.
The one that gives you the least amount is always the limiting reactant. Does that make sense?
Yeah.
The one that gives you the least amount is going to be the limiting reactant. So the maximum amount is no other than 500. The maximum amount was 5 sandwich. Why is that? Because the bread. Because the bread. You want more, really. You want 9 sandwich. You want 8 sandwich, by the way. Unfortunately, you can't because the bread will finish first. One of the reactants consumed first. Make sense?
The answer will be biological.
Oh yes.
That's just the way you react.
Yes. The maximum amount is going to be what now? 500.
So
The maximum amount
Yes.
is not going to be 550.
No.
it's just going to run out.
Oh, let's make this clear right now. Okay? Is it? Yeah. Because we're going to go more. I'm going to go. Yeah. Okay. Go ahead.
You said the limiting reactant will be the one that gives the least value.
The least product. Yes.
Which is 500.
Yes.
So which one is the maximum amount?
500.
It can only go
It's
up
also
to
called the maximum
500.
amount.
Yes, that's a maximum. Yes, that is the maximum ever that you get.
Yeah, when you
Oh,
get an answer, you just-
okay, I get you.
Exactly.
The maximum, okay.
That is the maximum ever. You actually, Tosi, you wanted to get more. I mean, always when you do chemical reaction, you are looking for the higher product. It is effective to get the higher product, but unfortunately, you can't look for the higher product. Yeah,
You can't finish all this today. No test.
Is it
No, we got like, whatever you percent, percent due, whatever. Or we should finish it like mine.
Does that make sense? Does that make sense, right? Okay. Okay. Please make sure you understand this. It's very important. I'm going to ask you this on the test. Okay?
Thanks, Lord.
I'm going to ask you this on the test. I have to be honest with you. In fact, I wanted to be honest with you here. The question, maybe the numbers might be different. The numbers might be different, but this question will be on the test. I want you to do, what's today? Wednesday?
Yes.
Okay, we have a Friday.
We're gonna have a test on Friday. Because we have like,
You may not have a test on Friday. You may not have a test on Friday, but you may have a pub quiz on Friday. How about Friday? Okay. I'm sorry.
Make your mind up. Is that a test or a pop quiz so we know what to prepare for?
Exactly.
Yeah.
There's no test.
There's no
There's
test.
no test.
Maybe.
There's no test, but there will be a pub quiz.
Okay.
There will be a pub quiz.
What about-
Maybe.
On
You say
limited
maybe.
reaction or on everything?
Of what we discussed.
Today?
Yes, of what we
Only
discussed.
today? Only today?
No, Friday we get a pub quiz.
Listen. First of all, I don't have to give you all this information because a pub quiz is a pub quiz, right?
Thank you.
But I can guarantee you that there is no test. But there will be a pub quiz.
Well, we're gonna have a spring break next week.
Exactly. That's why we come back.
Give me all that information.
Okay. As an assignment, we have only 5 minutes left.
Yeah.
Can we go one more question? Can we go over one more question? About
Can you tell us what we get to the pop quiz?
Okay.
Thank you.
Okay. Here is what I want you to do. Okay. How many of you have your textbook with you? Okay. Okay. Look on page 105. Look on page 105.
That's the old book.
This is the old one.
So let's
Can we just go over this question?
Sample exercise 3.18. 3.18. I don't have the new textbook with me, so
You
it's
have
going
the
to
new
be.
textbook, Madeline? You know it's going so.
Okay.
Have you
So
been textbook?
Okay, let's use this, Professor. There's a new textbook here.
that's the new textbook. Okay. Well, I'm going to read the problem, but try to make a.
Just tell us.
What page is that, Beverly?
If you're doing 3.18, it's page 106.
What's the question?
Is it a sample exercise or is it
Let me see. Oh, no, it is not, it's going to be,
Did you want to say?
I'll find it.
No, that's not
I'll
it.
find it.
it is a practice exercise that I want to do it is, you have a reaction, zinc plus silver nitrate. Okay, and it provides you silver plus what? Zinc nitrate, right? 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 This is a reaction. So, what is given to you? You have a zinc metal with a mass of 2 grams. Zinc has 2.00 grams, very significant figure. You also have 2.5 grams of silver nitrate. Right? Okay, zinc is given, which is 2 grams, and silver nitrate is given, which is 2.5 kilograms. Okay. Now, there are questions here. First question is, yeah, I'm coming. The first question is actually, okay, which reactant is limiting? Okay? Which reactant is limiting? Okay? The second question is, how many grams of silver will form? And how many grams of zinc nitrate you form?
From the limiting reactant, right?
Yes. In order for you to determine how many silver will form or how many zinc nitrate will form, you have to know which one is your limiting reactant. That's the key. You have to know which one. You have 2 grams of zinc. You have 2.5 grams of silver nitrate. If you close your eyes, you can't tell which one is the limiting reactant. What do we do?
Compare the ratio, the mole.
The mole ratio.
Well, it was given in grams here.
Do we have to find it, do you have to find it, do you have to change to mole, or we can just compare it?
Well, you can do that. You can do that. If you ask me what is my way, or if you ask me what's the best way, I'm not going to change mole. I'm not going to change grams to mole.
So
So
you can
the
just
zinc
say,
is
I can't just compare mass to mass.
The zinc then.
You know, why do I have to change it to moles? Why? I can say, what is the molar mass of zinc? 65.
65.
65 grams. That's from the periodic table. What is the molar mass of silver nitrate? Well, give me the molar mass of silver nitrate. From the periodic table. You have the I gave you the periodic table. It's a periodic
You didn't
table.
get the mass.
It's not.
The mass is on almost periodic table.
It is.
It's not.
It's not?
No.
Just the charge.
Well, this is helpful, really. I mean, this is helpful, but I thought I was guys, from the other instructor anyway. But you have your textbooks, so you can look from silver will be what?
108.
108. Silver is 108.
170.
Oh, silver nitrate. I mean, you're talking about silver nitrate 170?
Yeah.
The whole thing? Okay. But remember, you have to multiply this by 2.
340.
340, right? 340 grams. Okay, now, what we can do here, this is what I'm going to do. I have 65 grams of zinc that requires 340 grams of silver nitrate. Okay? If I have 2 grams of zinc. Zinc, yeah. 2 grams of zinc. How many grams of silver nitrate I need? Crisscross, right? So multiply 2 by 340, divide by this. What do you get? 2 times 340 divided by 65. Donna, you get what? 2 times 340 divided by 65.
10.46.
10.46. Okay. Just a minute. 10.46 grams of silver nitrate, right? I'm going to continue on Friday, okay? I'm not going to give you a pub quiz, don't worry. Okay? Don't worry, I'm not going to give you a pub quiz, but I just want you to understand this. You have 10.46 grams of silver nitrate. You have 2.5 grams of silver nitrate. Now let me ask you one question. Which one is your limiting reactant?
Zinc.
No,
2.5. Silver nitrate.
2.5 grams of silver nitrate is your limiting reactant.
Because like,
Wow.
is it because like you have a 2
Because
gram
you
and you
get-
like
you
Because
10.46.
2 grams of zinc, you need
10.46.
10.46 grams of silver nitrate. Unfortunately, you have the 2.5. I'm going to continue on Friday, okay? I'm going to continue on Friday.